Hello class, this is a video tutorial on applying Pythagoras' theorem to calculate the missing hypotenuse. As you can recall, in a right angle triangle, the Pythagoras theorem states that c, the hypotenuse, so c squared, is equal to the sum of these two squared, b squared. So we're going to use this principle to find the missing value of the hypotenuse in each of these. So here we go. What's important first is to make sure that we place each number into the right position of the Pythagoras' theorem. Take for example, x is the hypotenuse, so we'll leave x on its own. That's the hypotenuse, which means the other two values go on the other side. From this point, you can calculate this individually. So this becomes 9, 3 squared is 9, plus 4 squared is 16, and x squared stays the same. At this point, we can find out what these two are. That's 25 equals x squared, but that's x squared. What we want is the square root of this, because we don't want x squared, we want x by itself. And here's where our calculator can come in to play. We want to take the square root of 25, so the square root of 25 is 5. So our final answer is, I'm just going to switch these around. I'm just going to put x on this side equals square root of 25 is 5. Alright, I'll do a few more examples of this so you can get the hang of it here. Once again, we need to place the proper values in the right position. So the hypotenuse is y in this case, so it will be y by itself here to the side equals 5 squared and 12 squared. I'm going to make this a little bit faster here, just so I can make it a bit faster. I'm going to take 5 squared, show you in the light, 5 squared plus 12 squared. This will give me 169 equals y squared. Once again, I don't want y squared, I want y by itself. So to do this, we take the square root of both sides, which will give us y by itself, like so. We'll take the square root of 169, which is 13. Alright, here we go. Once again, we have 40, 9, and z. So we're going to put z by itself off to the side, z squared. This will give us now 40 squared on this side and 9 squared also on the same side of the equal sign. Now just a matter of the calculator. 40 squared plus 9 squared. This is 1681 equals z squared. We're going to take the square root of these values. So square root 1681. So z is equal to 41. Now, these first three examples are deliberately set up so we get nice round numbers. But in these next ones, you'll see what to do if we don't have nice numbers to work with. Here we go. So in this case, we have p by itself as the hypotenuse, so p squared. There will be 2 squared plus 7 squared. Okay, so 2 squared plus 7 squared, 53. 53 equals p squared. Now here we can do one of two things. If we take the square root of this, we know that this letter P becomes just P by itself. But if you try and do the square root of 53, gives us a strange number like this. So in this one, we're going to give you two answers. I'm going to title it just so you understand what we're doing. P, we can just take 53 in the square root. We can leave our answer just like this. And if the question were in centimeters, we can take the square root of 53 centimeters, and that there is our answer. But what we can also do is just take our decimal value like this, 7.28, and just round it to 2 decimal places. So we can say that this is also equal to 7.28 centimeters to 2 decimal places. Okay, let's do this again. This time, Q is the hypotenuse, so Q squared, and it'll give us 5 squared plus 7 squared. Adding all these together, 5 squared plus 7 squared is 74, which gives us Q equals, if we take the square root of both sides in here, Q will give us 74 square root. That's exact form. But if we take the square root of 74, this will give us 8.60 and whatever units to 2 decimal places. Okay, one last example here. Paper. One last example. We have in this example here, we have R as our hypotenuse, so R squared, and it will be 10 squared plus 13 squared. Okay, using a calculator, 10 squared plus 13 squared, that's 269 equals R squared. Taking the square root of both sides will give us R equals 269. Not a round number, so we'll just take it like so. We can also leave it as 16.40 at 2 decimal place values. Okay, hopefully I gave you an insight into using Pythagoras' theorem to calculate the missing hypotenuse. Best of luck!